Let's get a piece of scrap that you broke. Can I get a piece of scrap or loose leaf or paper out? Okay, so I want you to take the derivative of 4/3 pi r cubed. You don't like that. Is pi a number or is it a variable? It's a number. So you can take the derivative of that, right? The only variable in that case is r. Oh, wait, what do you get as the derivative of 4/3 pi r cubed?
4 pi r squared.
4 pi r squared. Does that look familiar to anybody? No, it's not a stupid circle, it's a stupid sphere. What's this? This gives us the volume of the sphere. What does that give us? Surface area of the sphere. There's again that direct relationship. Okay, what's the first step in taking the derivative of g of x in number 9? Where is it? Before you start to think about taking the derivative, Dylan, what do you think? Yes, I would write this as x to the negative 2. Okay, so I'm taking the derivative of x squared, was it plus x to the negative 2? Okay. So, now go back to Marissa, I'm annoyed her. What's the derivative of 2x, or x squared, I should say?
2x.
What's the derivative of x to the negative 2?
Negative 2x to the power of negative 3.
2x to the power of negative 3. Now, I have a question for you. It's not part of it. What would you want to take out as a common factor from this? Let's say I had set this equal to 0. What would you want to take out as a common factor? 2x to the negative 3. Take out 2x to the negative 3. That's going to leave you x to the 4th minus 1. Now, we can now solve this. X to the 4th is equal to 1, and 2x to the negative 3 is equal to 0. That has no solution. And this is equal to plus or minus 1. There's a solution. When would I want to set the derivative equal to 0? When do I want to set the derivative equal to a slope of 0? On x-intercepts. On a graph like this, where are the slopes of the original graph equal to 0? Maximums and minimums. So in this case here, we know we had either a maximum or a minimum at plus or 1 and minus 1. Because that's where our slope is equal to 0. What would we want to do with this one? Cube root of t And yes, I know going back and forth is very annoying, but we'll just use t for now. Before you want to take the derivative here. Now, there are other ways, but we do have the ability to take this derivative. What do you think you want to do first? Molly? And then what do you want to do? And so t to the power of 1/3 is equal to t plus 2. Now, we have not talked about how to do something multiplied by something. That's the moral point. So I'm going to 2 to the power of, or t to the power of 4/3 plus 2 t to the power of 1/3. I'm going to expand my guy in. That gives me h of t, my derivative with respect to t. I'm looking at the plus.
Just trying to figure out what you're doing.
Well, okay, what did I do from here
Oh,
to
no,
here?
I got it now.
Okay, so now, Molly, what's the derivative of t to the power of 4/3?
4/3.
And then plus 2/3 t to what power?
-2/3.
-2/3. So again, with something like this, if I wanted a factored form, let's say again, where do our tangents of the original function, where do they have a slope of 0? So maybe I have it 0. No, I don't want that. 0 is equal to, and I'm going to take out power. I'm going to take out 2/3. We're going to take 2/3 t to the -2/3, and that's going to leave me with 2t plus 1. And then I could solve this. This would not have a solution because it's 2 over 3 to the times t to the power of 2/3. Anytime you have a denominator on the bottom, you can never make it 0, and our one solution would be -1/2. Like that on the bottom. How about something like this? Here we have a function over a function. We have a polynomial over a radical. Again, we haven't talked about how to find the derivative of a polynomial over a radical. It's called White product. Is there a way to simplify that? Well, splitting the product. I'm going to think about it, and I probably wouldn't write this down. I'm going to think about it like that. Okay. This, because it's a monomial denominator, I can do that. Okay. You're not really able to do that in other cases. So we have y is equal to the x to the power of 3/2 plus 4 times x to the power of 1/2 plus 3 times x to the power of -1/2. Which now we've turned it into something that we could apply the power rule and the sum rule on. Y prime is equal to 3/2 x to the half plus 2 x to the -1/2 plus minus 3 halves times x to the negative 3 halves. And yes, I could turn this back into a polynomial by taking out 3 halves x to the negative 3 halves. That would be x squared. That would be plus 4/3 x to the 1 minus 1. Not perfect by any stretch, but it does work. Or again, just take it out a half x times x to the power of negative 3 halves. Would give me less of a, would not give me a fraction in my answer, but yeah, this idea of taking out something that's common can be very useful. Because I could probably solve this again, right? I could figure out solutions using the quadratic formula with this. 3 plus 4 minus 3, I'd have to use the quadratic formula for that. If I set it equal to 0. So think about what's there. You can sometimes trick it so you don't have to use the product rule as we would have had to use here, which we have not another rule. But we could use the product rule or we could expand it out. We could use the quotient rule or we could split the fraction. Sometimes it works, sometimes it doesn't. And let's take a look at 29 here. What do you think you want to do to 29? What's x times square root x? What's another way of writing x times square root x? X to what power? What's square root x? How do I write square root x? Now I have x to the power of 1 times x to the power of 1/2, so I now get x to the power of 3 halves plus 1 over x to the power of 3 halves. And taking the derivative from there is very simple. Right? It's not simple here. A little bit of mathematics, exponent laws essentially, then it becomes, oops, that's not a prime. And then this, y prime, 3 halves x to the 1/2 minus 3 halves x to the negative 5 halves. So 1 less than 3 halves. Like I said, you can simplify that a little bit if you want. Another way of writing. But if you guys have any questions on those questions I asked you to work on yesterday. Let's go to do some of the problem solving before we go on to some more problem solving on homework. Okay, so here we have a relatively simple one. Find the equation of the line tangent to this curve at the point 2, 4. So y is equal to x plus, I can read that's awful short. we need, or the two things that we need to find the equation of the tangent line? But two things can you need to find the equation of any line? Okay, I need the slope. Okay, I could use the y-intercept. Any point will do though. I need the slope. So how do I calculate the slope? The slope is found by taking the derivative. Now, we don't have to use the definition of a derivative for this. I'll just, again, do that. So my derivative is 1 minus 4 over x, or 4 times x to the negative 2. That's my derivative. At what point do I want to find my slope? At the point x is equal to 2. So y prime is equal to 1 minus 4 times 2 to the negative 2. So we have y prime is equal to 1 minus 4 over 4. Y prime is equal to 0. So actually I should redo my notations with that. It should be y prime at 2 or both of them. So my equation of my line is y is equal to 4. And if you kind of look at the graph here, you can see when I plot those two things, we end up with a line tangent at the point 2, 4. So once we found that this was equal to 0, what does that tell me about that point? Without looking at the graph, it's either a maximum point or it was a minimum point. In this case, it worked out to be a minimum point. We'd have to do a little bit more work to figure that out. Because it has the slope of the line tangent to the graph is equal to 0. So,
Okay.
right, it looks like this. So once it's
I thought you
turning,
meant from looking at it. The first
No.
equation, we should have known that.
looking at once you find that 0. Okay. Question 43. At what point on the curve y is equal to x square root x is a tangent line parallel to the line 3x minus y plus 6? So we have y is equal to, and I'm going to write this as x to the power of 3 halves. I automatically get rid of square root signs. And then we had 3x minus y plus 6, I think. Doesn't remember. So I'll tidy this one up to be equal to y is equal to 3x plus 6. What's the slope? The slope of this line is 3. We want to know the point at which a line tangent to this function has the slope of 3. We need a line tangent, or we have to find something that gives me the slope. So again, that's derivative. So dy dx is equal to 3 halves x to the power of 1. Since this is our equation for our slope, we set it equal to 3. So x to the 1/2 is equal to 2. And then what would I do? Okay, so I just divided both sides by 3/2, or multiplied by 2/3, it doesn't matter. I have to square this. X is equal to 4. Now, the question asks, at what point or points? In this case, it works out to be point. What do you need to describe a point? What two things do you need to describe a point? X and Y. So am I going to take this back into my derivative, or am I going to take it back into this? The top guy. Because we don't care about what point's on the derivative, we're caring about what point is on the original graph. So y is equal to 4 to the power of 3/2. So the point is 4, 8. Square root of 4 cubic. Now the question doesn't ask what's the equation of the line that is tangent to it, but we could take it that next step and find the equation of the line that passes through the point 4, 8 that has a slope of 3. Okay. So, that. I do get the feeling I'm talking to myself. Okay. So for what values of x does the graph of 2x cubed minus 3x squared minus 6x plus 87 have a horizontal tangent? Molly, what is the slope of a horizontal line? So m is equal to 0. Okay. So we're only looking for the values of x this time. I guess I might want to write that down. Out of there. Okay. Dylan, or sorry, 8. What's the derivative of 2x cubed? Y x 6x squared minus minus 6. Okay. So, and the 87 has the derivative of constant is equal to 0. So we want 6x squared minus 6x minus 6. We want to know where that has a slope of, at what point, or points in this case, that equals 0. Instead of factoring, I'm going to take out a common factor of 6. Okay, two numbers that multiply to -1 and add to -1. They don't work. So what do you have to do at this point? How do I solve this equation when I cannot factor? Thank you. X is equal to -b plus or minus the square root b squared minus 4ac over 2a. In this case, we have 1 plus or minus 1 square root of 1 minus 4 times 1 times minus 1, thankfully, over 2. So the x coordinates are 1 plus square 5 over 2, 1 minus square 5 over 2. So again, this tells us that we have, because of this horizontal tangent, this is going to be, these two are going to be our maximum or minimum. There's turning points at that point, which makes sense because this is a cubic function, and a cubic function can go like that, 2 turning points. So you have probably have a maximum there, probably have a minimum there, just by the sketch. Anybody awake today? Really? Okay, so 46 is a kind of question that I did earlier, where we want to know the coordinates of the points where the tangent lines intersect the parabola. So we want to draw a diagram to show that there are 2 tangent lines to the parabola y is equal to x squared that pass through the point 0, -4. So we know what the parabola y is equal to x squared looks like. It is opening up with a vertex turning point at 0, 0. We have down here a point 0, -4. Going to be a point tangent there, some point tangent there. Okay. Okay, so where do we go from here? Well, we go for the derivative, for one thing. Y prime is equal to 2x. This point over here is going to be x, y. This point over here will be negative x and y. Now, why did I put x, y, and negative x, y? What's so special about the parabola that I drew? It's symmetrical about the y-axis, right? So, now, what's the slope of this line? This is going to be y plus 4 over x minus 0, right? That point. And that's going to be equal to 2x. Because this is giving us our slope. We have a bit of a problem here. I have 2 variables, and I want to solve for one of them. What's another way of writing the y coordinate for this function right now? It lies on the graph of x squared. So I can replace, this would be x squared. So I'm going to replace this y with that. So I have x squared minus 4 is equal to 2x squared. Oops, I lost the plus sign. That doesn't work otherwise. There I have 4 is equal to x squared by subtracting my x squareds on both sides. X is equal to plus or minus 2. Y is equal to 4. So these points are actually 2 and 4, -2. Don't lose signs like I just did. Hurting your head or just Dave's hurting?
Oh, yeah, but I was going on, so that's okay.
It doesn't bode well considering I'm half your day.
What happened?
And let's do question number 49. Okay. Show that the curve 6x cubed plus 5x minus 3 has no tangent lines with a slope of 4. And we want to show that at no point will m equal to 4 on this graph. Okay, so again, the slope, we need the derivative. So how do I know that this would never have a slope of 4? Let's set 18x squared plus 5 equal to 4. So if we were to have some point that had a slope of 4, we would have to be able to solve this equation. 18x squared is equal to -1. X squared is equal to negative. You can stop at this point anyways. Doesn't matter. Because at no point, there's no solution to this equation, right? Nothing squared times 18 is going to give me -1. So our answer is, since so here's the next question. What is the shallowest slope that this equation could have? What's the lowest number that goes here that's going to make the solution this equation have a solution? Yeah. 18x squared plus 5 is equal to 5 has a solution. Anything less than 5, not going to have a solution because we're going to have something squared equals to a negative value. So the lowest slope on that guy is going to be 5. can see what that graph looks like. It's just going straight up, more or less. Could it have a negative slope? No, because we'd end up with a larger negative number. So there's no negative slopes in it. So that's a bit of the problem solving before we go on. So what I would like you to do for homework today, page 83, 3, D, E, F. Seven, 8. And page 88. Number 4. Number 7. And number 8. And I'd like to give an extension question to that. Is number 9. I would like you to have those